Hello, class, and this is Mr. Eggleston once again. This is the CYU for Lesson 8.2, Exponential Functions. The main thing we got, one of the big things we got from our discussion from our this lesson is that is your model for exponential functions. Y equals A times B to the X. Now here is number one. Scientists are interested in population of wasps and begin recording the number of wasps in the area each week. Initially, there are 228 wasps, and this number is growing by a factor of 1.25 each week. Complete the table with the number of wasps each week. So they already put in for us the initial value. That is, there were 228 wasps initially. Then after 1 week, that would be equal to 228 times 1.25 to the first power. All right? And that gives us 285 wasps. And then on the second week, we take the 280, it's going to be, I'm just going to go ahead and use the formula. It'll be 228 times 1.25 to the second power. And that gives us 356 wasps. And then to the third week would be 228 times 1.025 to the third power, and that's going to equal 445, rounding to the nearest whole number. Okay, and the last for 4, it'll be 228 times 1.025 to the fourth power, and that equals 557 wasps. The fifth week, it's just like before. You need a calculator. 228 times 1.025 to the fifth power, and that equals 696 wasps. So it's growing pretty quickly. It says write an equation for the number of wasps each week. So W of T is going to equal 228 times 1.25 to the T power. Okay, where T equals the number of weeks, or the week number. Does your equation make sense for negative values of T? Explain. No. A negative number of weeks is before they started measuring. Okay. You have no idea for the prior weeks how the number was behaving. If you could assume that behaved in the same manner, in which case you could then go towards the negative, which just means it was like the week before you got your first count and so forth. But that's making an assumption. Does your equation make sense for non-whole number values of T? Yes. This would represent days in the middle of the week. Okay. The next statement. The cost to manufacture a semiconductor device found in computer chips can be described using the function C of t times 3/4 to the t power. 8 times 3/4 to the t power, where C of t is the cost. Always know what your variables means. It's a cost in dollars, and t is the number of years since 1960. How much did it cost to manufacture a transistor in 1960? In 1960, that is t equal to 0, because t is the number of years after 1960. So that is C of 0 is equal to 8 times 3/4 to the 0 power, which is 8. So how much did it cost to manufacture a transistor in 1960? It cost $8 from our model. So the cost of the manufacturing a transistor increasing or decreasing? How do you know? Well, the cost is decreasing because R, the common ratio, the number we're multiplying by, the base of the exponent is 3/4, which is less than 1. So each time you multiply it by 3/4, it gives you a result that's less. For example, C of 1 would be 8 times 3/4, which would be 6. And then when you go C of 2, it'll be 6 times 3/4, which is 4 goes into 6 3 times. And so it'll be 9/2 times 8, I guess. I can't do it in my head. But it's decreasing. So now, what is the cost of manufacturing a transistor today? So today is the year 2026. So T would be 2026 minus 1960. That is the years since 1960. And that's 40 plus 26 is 66. So T is 66. It's 66 years ago. All right. And so we just plug that in. We want to know what is C of 66. That's going to be 8 parentheses 3/4 to the 66 power. All right? And when you type that into your calculator, you're going to get a really scary looking number. Just to show you, it is 0.75, that's 3/4, raised to the 66 power. That decimal is, look at that, 0.0006. It's a really tiny, tiny little number. So I got to use a little bit better calculator. So I'm going to go ahead and use Desmos. So that is going to be we're calculating 8 times 3/4, which is 0.75, raised to the 66 power. And notice it says 4.54 times 10 to the negative 8. Okay, what that means, that's scientific notation. That means that's a shorthand way of writing 0.000001234567. Then it'll be 454. That's the cost. That's how small the cost of producing a transistor, I think this is a transistor, right? Transistor is a semiconductor, is today if that model held. I'm not sure that model holds. I think there is a lower bound to it because it can't just, because if you think about it, if it goes on forever, it'll just keep getting smaller, and that doesn't make sense. But that's how much money it would cost to produce a transistor today. I hope that made sense. Have a great day. Bye-bye. Come on.